All right, I'm Nick. I'm doing the gas turbine electric generation system. The gas turbine was first invented in 1791 by John Barber, Englishman, who created the first true gas-powered turbine. It wasn't used for power generation until 1895, and not used for propulsion or flight until 1930. How it works is first the air is taken in through the intake and passed into the compressor. Depending on the size, the compressor has several different fans that compresses and heats the air as it passes through it. And then once it is through the compressor, it's put into the combustion chamber, and the heated, pressurized air is mixed with fuel. Fuel is injected, depends on what kind of fuel it is. But it is ignited and causes a chemical reaction that really is a high release of energy. The high release of energy is passed in through the turbines, which changes the chemical energy into rotational energy. And the large turbines are connected to the central shaft. And the shaft is actually connected both to the compressor, which powers that, and to the electric generator. And the electric system, the shaft is connected to the alternator, the large magnet in the alternator, which is surrounded by copper coils, which creates the electrical current. So you transform your chemical energy to mechanical energy to electrical energy, and these can produce a lot of horsepower. The largest right now is GE created. It's called Harriet, and currently producing 500,000 bhp. Why these generators exist is the main reason is to supplement other power plants like a steam engine. Say if everyone needs power at the same time during winter when it's cold, these supplement those when they do not have enough energy to provide to the network, or when they need maintenance and shut down, these gas turbines take over. And also to increase the power and efficiency, here this is GE's, where they use the heat from the exhaust of the turbine to heat the steam for the steam turbine, which they claim produces 50% more power. And for our experiment, we'll be using the turbogen. The turbogen, which is originally designed for energy conversion research. And even though it's much smaller than the ones we see in power plants, we know through like fluid dynamics that we can use dimensionless analysis to scale it. It has a SR30 gas turbine engine, which can generate a maximum of 87,000 RPM. The turbine is connected to a TG2000 generator, which has a maximum current of 194 amps. And the other cool thing about this is that it's on pivot bearings, which allows us to calculate the thrust as we throttle up. The main reason that we add the turbogen is so that we can test the many different fuels, biofuels, experimental fuels, and any other kind of liquid fuel. We tested for the operating characteristics, energy to power conversion, the efficiency, and for the emissions that they produce. And the lab that we're doing is broken into 5 main parts. The first is the system overview. We learn how to work the components, and also we'll be doing the main operation of the turbine. And yeah, the startup and operation again shut down. Second part is the data collection, where the sensors that are placed throughout the system collect the pressure and temperature in every part. We'll be transferring it to Excel. System analysis is the third part, and where we do the work, the compressor, the heat added, the work of the turbine, and the efficiency of the turbine. And how we'll do this is that every sensor will calculate the pressure and temperature and we'll use the air charts to find the enthalpy. And fourth is performance analysis, and this will be done using these equations. The C is the speed of sound, M is the Mach number, F is the thrust force, and then lastly we will calculate the generation of performance analysis, and this will be using the thrust-specific fuel consumption, the weight of fuel burned per hour over the thrust force. And we have to find determine the optimal working conditions for the SR30, so how much thrust to put on it into where it gives us the best efficiency out. We have to graph the performance and the voltage output, and we have to calculate the specific fuel consumption. And then once we're done with that, we are done with the lab, and we know more about the turbine. That's pretty much it.